Ivar Fredholm, a pioneer in functional analysis and integral equations. Early life and education. Ivar Fredholm was born on April 7, 1866, in Stockholm, Sweden. Growing up in an academically inclined family, he developed an early fascination with mathematics and the sciences. This early interest set the stage for his lifelong dedication to mathematical inquiry. Fredholm pursued his higher education at the University of Uppsala, a prestigious institution renowned for its strong emphasis on mathematical studies. After completing his undergraduate degree, he continued his education in Paris, where he was influenced by some of the leading mathematicians of the time, including Henri Poincaré and Émile Picard. Academic career. Fredholm returned to Sweden to complete his doctorate at Uppsala University, focusing on topics that would lay the groundwork for his later work on integral equations. His dissertation was a precursor to his major contributions to functional analysis and integral equations, which would become the most significant areas of his research. In 1898, Fredholm was appointed as a professor of theoretical physics at Stockholm University. This position provided him with the platform to further his research while mentoring a new generation of mathematicians. It was during his tenure at Stockholm University that he produced his seminal work on integral equations, which would later bear his name. Key contributions. Fredholm, integral equations. Fredholm's most notable contribution to mathematics is his work on integral equations. In his landmark paper published in 1903, Sur une nouvelle méthode pour la résolution du problème de Dirichlet, Fredholm introduced a new type of integral equation, now known as the Fredholm integral equation. These equations are of the form phi x lambda int underscore a circumflex bkx ta phi t dt equals sine fx, where phi x is the unknown function, kxt is the kernel of the integral equation, fx is a given function, and lambda is a parameter. Fredholm developed methods to solve these equations, which involved transforming the integral equation into an infinite system of linear equations. He introduced the concept of the Fredholm determinant and Fredholm alternative, which provided conditions for the existence and uniqueness of solutions to these equations. His work laid the foundation for modern functional analysis and had profound implications for various fields, including mathematical physics and differential equations. Functional analysis. Fredholm's work on integral equations significantly contributed to the development of functional analysis, a branch of mathematical analysis dealing with function spaces and linear operators. His introduction of concepts such as compact operators and the Fredholm index theorem played a crucial role in the evolution of this field. The Fredholm index, which is the difference between the dimensions of the kernel and cokernel of an operator, became a central concept in the study of linear operators in Hilbert and Banach spaces. Influence on spectral theory. Another important aspect of Fredholm's work is its influence on spectral theory. His methods for solving integral equations and his study of the properties of integral operators provided a framework for the development of spectral theory. This theory, which deals with the study of eigenvalues and eigenfunctions of operators, has applications in quantum mechanics, wave propagation, and many other areas of physics and engineering. Teaching and mentorship. As a professor at Stockholm University, Fredholm was not only a dedicated researcher, but also a passionate educator. He mentored several students who would go on to make significant contributions to mathematics. His teaching style was known for its clarity and rigor, inspiring students to pursue deep mathematical inquiries. Fredholm's commitment to education helped establish a strong mathematical community in Sweden, fostering the growth of future mathematicians. Awards and recognition. Ivar Fredholm's contributions to mathematics did not go unnoticed. He was elected a member of the Royal Swedish Academy of Sciences in 1906, a testament to the impact of his work. His ideas were recognized internationally, influencing prominent mathematicians such as David Hilbert, who extended Fredholm's theories in his own work on integral equations and functional analysis. Publications and legacy. Fredholm's 1903 paper on integral equations remains one of his most cited works, marking a significant milestone in the history of mathematics. His contributions are foundational in the study of integral equations and functional analysis. The Fredholm alternative, Fredholm determinants, and Fredholm operators are standard topics in advanced mathematics curricula, ensuring that his legacy endures. Beyond his specific mathematical contributions, Fredholm's work exemplifies the power of abstract mathematical theory to solve practical problems. His methods have applications in physics, engineering, and beyond, demonstrating the broad relevance of his theoretical insights. Later years and death. Ivar Fredholm continued his research and teaching activities throughout his career, maintaining an active role in the academic community. In his later years, he focused more on the applications of his work, exploring how his theoretical findings could be used to address real-world problems. Fredholm passed away on August 17, 1927, in Stockholm, leaving behind a rich legacy of mathematical innovation and discovery. Conclusion. Ivar Fredholm's work has had a lasting impact on the field of mathematics. His pioneering research on integral equations and functional analysis has influenced countless developments in both pure and applied mathematics. Fredholm's innovative approach to solving integral equations and his contributions to the theory of linear operators laid the groundwork for many modern mathematical theories. His legacy continues to inspire mathematicians and researchers, ensuring that his contributions will be remembered and built upon for generations to come.